Before I go ahead, let me explain the structure of the entire chapter we have. This entire chapter is divided into two parts. One is called fluid statics. That means you will be talking about the properties of fluid when it is stationary. And the second part is fluid dynamics. Fluid dynamics means properties of fluids when they are in motion. In fluid statics part, you have again two areas. One is called pressure. Connected to this is another chapter that is called buoyancy. These two are interrelated, however, we are supposed to cover these two in two different lectures. The other part of fluid statics will be called surface tension. This we will be covering in third lecture. And in fluid dynamics part, you have real fluids. You have real fluid. Real fluids are recognized by their properties of viscosity. So basically, we will be covering the topic of viscosity here. And in case the fluid is ideal, ideal fluid, that means it will not have the properties of viscosity, and they are a very famous relation, famous principle that is called Bernoulli's principle that will be discussed. So once we have divided this entire chapter into 4 lectures, in first lecture today we will cover pressure. Then in the next lecture we will cover this buoyancy. In the third lecture we will cover this surface tension part. And in the fourth lecture we will be completing this fluid dynamics part and the chapter will be over. So let us today begin with this part that is called pressure. In the topic of pressure, let us first try to understand what is the meaning of density of a fluid. Density of a fluid however, this particular relation is valid for a body as well. Right now, in this particular topic, we are concerned about fluids. Fluids means liquid as well as gases. So it has been defined as that mass of the substance upon volume. Mass of the substance upon volume of the substance, that is defined as density of that substance. Whether it is either a case of solid or liquid or gas, this particular formula will remain intact, and the unit you will be using here, that will be kilogram per meter cube. You understand, the unit you will be using for density, that will be kilogram per meter cube. Now we have set a standard for density, and that is of water, and at 4 degrees Celsius. Because at 4 degrees Celsius we have experienced that the density of water happens to be maximum. So we have taken density of water. We have taken density of water at 4 degrees Celsius as standard you have taken as standard equal to 1000 kilogram per meter cube. We have taken the density of water as standard, and at 4 degrees Celsius it is 1000 kilogram per meter cube. Now based on this, you can define another term commonly used, and that is called relative density. Relative density this term relative density is also called specific gravity. This is also called specific gravity of a substance. Specific gravity or relative density of a substance is defined as density of substance upon density of water at 4 degrees Celsius. You understand? This is another term we have found, that is relative density or specific gravity of a substance. It is equal to the absolute density of that object or substance upon density of water at 4 degrees Celsius. So you can clearly see this will not be having a unit. It will just be a number. In case the relative density comes out to be 2, that means the density of that substance is 2000 kilogram per meter cube. You understand? In case the density of an oil, let us suppose relative density of an oil is given to be 0.9. That means the absolute density of that substance is 900 kilogram per meter cube. So these are the two terms frequently we will be using in this entire discussion. So we have defined what is the meaning of density of the substance, what is the meaning of relative density of the substance. Now let us define what is the meaning of pressure. Pressure is defined as, now pressure is equal to force upon area. Now you have to understand that the area here, area is taken to be perpendicular to the force. Area is perpendicular. Area is perpendicular to the applied force. Area is perpendicular to the applied force F. This F is basically force, and this area is taken to be in a direction perpendicular to the direction of force. If you talk about the SI unit of pressure, that is written as Newton per meter square, and this Newton per meter square is also called Pascal, in the honor of the scientist Pascal. Symbolic representation will be PA. You understand? This is the SI unit of pressure. There are some other practical units. You can say you should be very much familiar with all the practical units you will be having. Other practical units. One atmospheric pressure, that is denoted as 1 atm, 1 atmospheric pressure. This is approximately 1.01 into 10 to the power 5 Newton per meter square. You understand? So you can say 1 atmospheric pressure is around 1.01 Pascal, that can be written as. Then you have another unit called 1 bar. 1 bar is 10 to the power 5 Newton per meter square. So you can say 10 to the power 5 Pascal, that is indicated as 1 bar, because atmospheric pressure is of the order of 10 to the power 5 Newton per meter square. That is why fixed unit, that is bar, has also been defined. Now in medical field, commonly you have seen the blood pressure is mentioned in terms of say 120 by 80 or 130 by 90. So that is essentially a unit called torr. This is another practical unit. TORR, torr, is in the honor of the scientist Torricelli, who did a lot of contribution in this particular area. 1 torr pressure is basically 1 millimeter of mercury pressure, Hg pressure. We will understand the meaning of this mercury pressure as the discussion will carry on. These are some of the practical units. You can use another unit that is very much common in foreign countries, and that is in FPS system. That is, you can say 1 PSI. PSI stands for pound per square inch. You understand? 1 PSI, this is 1 pound per square inch. So this is FPS system. If you think of conversion or relation between PSI and other units, then for your convenience we can say 1 atmospheric pressure is approximately equal to 15 PSI. 1 atmospheric pressure is approximately equal to 15 PSI. So apart from the standard unit of Newton per meter square, these are the other practical units you will be using frequently in your discussion. That is atmospheric pressure, bar, torr, and PSI. These are the only other units which are used for pressure. Now let us derive a very important and starting equation for this particular lecture, that is pressure is equal to rho GH. Now let us derive a very important relation, that is pressure is equal to rho GH. P here stands for pressure exerted by a fluid. Here rho stands for the density of the fluid. So I will write it down. Rho stands for density of the fluid. Rho stands for density of the fluid. You can assume that there is a liquid column. This is a liquid column. Of height h. This is a liquid column of height h. That means this total height you see here, this is equal to h. And here you can say this liquid column is in a cylindrical vessel whose cross-sectional area is A. Here A is, you can say, cross-sectional area. As it has been shown in the diagram, you can see, let's suppose the liquid is filled completely You understand? This is completely filled here. Now due to its weight, the liquid must have been exerting pressure here. You see here, this liquid must have been exerting pressure. You understand? So you can define now pressure as this pressure exerted by this liquid will be defined as weight of the liquid, weight of the entire liquid that will be applying the force upon area. You understand? Weight of the liquid upon area. For example, here you see whatever the entire liquid has the weight, that weight is essentially applying the pressure here. That weight is acting as force which is being applied on the surface area A here you have. So that is what we have written here, weight upon area. Weight can also be written as mass of the liquid multiplied by acceleration due to gravity, mg, weight is mg, upon this area. You understand? Weight is mg and area is area. Now mass can be written as density into volume. Understand? This can be written as density of the liquid multiplied by volume of the liquid. So density into volume, this becomes equals to mass, and this acceleration due to gravity g upon this area. Understand? So this is the expression for pressure. Now if you can further simplify it, you can say density is indicated by rho. Volume is what? Volume is, this is a cylindrical vessel, so cross-sectional area multiplied by height, this will be the volume. Then acceleration due to gravity g and divided by this area, cross-sectional area. You understand? This is the entire weight of the liquid and divided by the cross-sectional area. Now if you cancel this A, it makes it rho g h. You understand? Pressure applied by a liquid column, that comes out to be rho g h.